Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on implementing VRRP. So let's go ahead and read our objective for this lab. It says first hop redundancy protocols, or FHRPs, are technologies that provide router redundancy and high availability for Cisco networks. There are a number of different HSRPs, each of which differ in scalability and support among vendors. One such FHRP is VRRP, a Virtual Router Redundancy Protocol. In this lab, you will implement VRRP to learn how VRRP behaves. So if we take a look at our lab topology, we can see that we have two routers. We have router 1 and router 2. We have D-switch 1 and D-switch 2, which are layer 3 switches. And then we have layer 2 switches as well, which is A-switch 1 and A-switch 2. We can see that we have host 1 and host 2 connected off of this access layer switch, or access layer switch number 1. And then we have host 3, host 4, and host 5 connected to access switch number 2. So these access switches give our in workstations access to the network. And then we're using FHRP, so we're most likely going to be configuring the first hop redundancy protocols on these layer 3 switches, which will be D-switch 1 and D-switch 2. All right, so let's go ahead and take a look at the command summary that we're going to be using throughout this lab. We have configure terminal, which enters global configuration mode from privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends in exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP config, which displays the IP address configuration on a PC. We have IP config / default gateway IP address. This configures a default gateway on a PC. We have show VRRP, which displays the VRRP information. We have shutdown, which disables an interface, and we have no shutdown, which enables an interface. We have VRRP group number and IP, and then you specify the IP address. This creates or enables the HSRP, or this should say VRRP. I think this is a typo within Boson. It should say curate or enables VRRP group with a group number and virtual IP address. We have VRRP group number preempt. This enables preemption for VRRP on a device. Again, this is a typo. It should say VRRP. And we have VRRP group number priority, and you specify the priority. This sets the priority value used in choosing the active router. The default value is 100, and the configurable priority value range is from 1 to 255, with 255 being the highest priority. And then we have trace RT IP address. This traces the path from a source to a destination on a PC. So Boson also includes an IP address table, which we can refer to throughout this lab. It includes the device name, the interfaces, the IP addresses configured on each interface, and the subnet mask on each interface, okay? So we have that for the host as well. So let's go ahead and hop into our lab task. We're going to keep our topology up here at the top left. We're going to be doing our lab readings in the top right. And we're going to be doing all of our configuration down here at the bottom. All right, so let's go ahead and get into task number 1. It says explore the routing topology. It says in this task, you will explore how packets are routed from one host to another. You will determine from your experimentation how a problem or misconfiguration might affect the network. So it says on host 1, issue the command to display the IP address configuration. What device is the default gateway for host number 1? So let's go to host 1. We're here now. Let's do an IP config to take a look at the IP configuration information that is configured on host 1. And if we look, we can see our default gateway is 192.168.100.3. So let's go down to our IP address table to see what device that is. If we look, we can see D-switch 1's VLAN 100 has that IP address of 192.168.100.3. So we can see that D-switch 1 is the default gateway for host number 1, okay? So we can see host 1 right here, and its default gateway is D-switch 1. All right, let's go ahead and move on to number 2. It says from host 1, issue the command to trace the route to router 2's loopback 0 interface which is 172.16.1.2, along what path is the packet from host 1 forwarded. So we're going from host 1 to router 2. So on host 1, we're going to do a ping, but not a ping, we're going to do a trace route because we want to see the route. So let's do a trace RT to 172.16.1.2. All right, so we can see our first hop was D switch 1. We already looked at that IP address. The next hop was 192.168.100.1. Let's take a look at that IP address. 192.168.100.1 is router 1's fast Ethernet 10 interface. And then the last hop was 203.0.113.2. If we take a look, that is the fast Ethernet 00 on router 2. All right. So the path was from D switch 1 to router 1 to router 2. Okay. So let's go ahead and move on to number 3. It says from host 5, issue the command to trace the route to router 1's loopback 0 interface, which has an IP address of 172.16.1.1. What device does host 5 use as its default gateway? Let's go to host 5. And it wants us to do a trace RT. So let's do a trace RT to 172.16.1.1. Oops, typo. 172.16.1.1. Okay, so the first hop was 192.168.100.4. So that is our default gateway. So if we go down to our devices in the IP address table, we can see that that is D switch 2's VLAN 100 interface. So that is host 1's default gateway. D switch 2 is. So that was our first hop, 192.168.100.4. The next hop was 192.168.100.2. We take a look, we can see that that is router 2's fast Ethernet 10's interface. And the last hop was 203.0.113.1. And that is router 1's fast Ethernet 00's interface. So from host 5, the traffic went from host 5 to D switch 2 to router 2 and then to router 1. Okay. So number 4 says on D switch 1, issue the necessary command to disable the fast Ethernet 02 interface. Do you think host 1 and host 2 will be able to trace paths to router 2's loopback 0 interface now? So let's go to D switch 1 and let's do an enable. Let's do a configure terminal. Let's go into interface for VLAN 100. Oh, no, we don't. We need to go into fast Ethernet. We need to go into interface fast Ethernet 02. We want to do a shutdown. Okay. So the question was, do you think host 1 and host 2 will be able to trace paths to router 2's loopback 0 interface now? So host 1 and host 2 are connected to a switch 1, which then connects up to switch 1. And as we know, host 1 and host 2's default gateway was D switch 1. And we just disabled the connection from D switch 1 to router 1. So now, because of that, host 1 and host 2 will not be able to reach destinations past their network, which is 192.168.100.0. So they will not be able to trace route, be able to go out to router 2 in this situation, because we just disabled the link that D switch 1 uses to get outside of its network, which is router 1. We do not have this connection anymore. So now D switch 1, after it gets the traffic, it will not be able to forward it past its network. Okay. So number 5 says from host 1, issue the command to trace the route to router 2's loopback 0 interface, which is 172.16.1.2. Is the trace successful? Why or why not? So we're about to prove that it's not going to be able to work. Let's prove it. So as you can see now, before the next hop worked, it went straight to router 1. As we can see, now we're getting asterisks, which means that the destination host is not reachable. It can't get past the first hop, so it gets to D switch 1, and then D switch 1 from there cannot forward the information. We're going to continue to get these asterisks. I'm going to let it do it one more time because I believe trace RT does it 20 times by default. Let's do Control C to break out, and as we can see, the trace route was not successful. So So number 6, it says, on D switch 1, issue the necessary commands to enable the fast Ethernet 02 interface. Let's go back to D switch 1. Let's do a no shut to bring it back up. And number 7, it says, how might configuring a first hop redundancy protocol like virtual router redundancy protocol benefit the network in this scenario if D switch 1 or D switch 2 goes down? So as we know, first hop redundancy protocols gives us redundancy within our network for our default gateways. So if one of our default gateways, which is D switch 1 or D switch 2, goes down, the other one, which will be, in this case, since we're using VRRP, we will be using master and backup. If the master fails, the backup will take over as the master. Okay? So it gives us some redundancy. So our in-host in this situation will still be able to get out to the internet even if one of these default gateways goes down, because they will be using the same virtual IP address and same virtual MAC address once we configure the first hop redundancy protocol. Okay? So let's go ahead and move on to task number 2, which says configure virtual router redundancy protocol. It says in this task, you will configure VRRP in order to provide router redundancy for the network. You will then explore how this redundancy helps prevent network downtime. So number 1, it says on D switch 1, issue the commands necessary to configure VRRP on the virtual LAN 100 interface. Use a group number of 100, set a priority of 90, and set an IP address of 192.168.100.254. What VRRP role does D switch 2 assume after you issue these commands, and why? So on D switch 2, let's go there first. Let's do an enable, do a configure terminal. Let's go into interface for VLAN 100. And we want to do VRRP 100. And we want to do the priority first of a 90. Hit enter. Let's do VRRP 100. Let's set the IP address to 192.168.100.254. Hit enter there. And as we can see, D switch 2 has went into the master role. And it says, why does D switch 2 assume this role? Well, it assumes this role because it is the only layer 3 switch in our topology that is configured with group 100 and the IP address that we configured, which is 192.168.100.254. So because it's the only layer 3 switch that we have configured, it is, of course, the master. Okay? So number 2, it says on D switch 1, issue the necessary commands to configure VRRP on the VLAN 100 interface. Use a group number of 100, set an IP address of 192.168.100.254. Based on the output you receive after you complete this configuration, what do you think the earlier configuration steps accomplished on D switch 1 and D switch 2? So if we go to D switch 1, let's do a exit. Let's go into interface for VLAN 100. And let's do VRRP group 100. We want to set the IP address of 192.168.100.254. Hit enter there. And now if we take a look, we can see that D switch 1 has taken over as the master. And the question asks, based on the output you receive after completing this configuration, what do you think the earlier configurations accomplished on D switch 1 and D switch 2? Well, we configured both of these layer 3 switches to use the VRRP group of 100, and they both share the same IP address of 192.168.100.254. The only difference is on D switch 2, we configured the priority to be 90. And we configured the D switch 1 with no priority, which basically is going to use the default of 100. So because of that, D switch 1 has a higher priority, and because of that, it has now taken over as the master. As we know, preemption is automatically enabled with VRRP. So once a network topology change occurs, in this example, D switch 1 came online, it has taken over as the master layer 3 switch, or the default gateway that all of these in-hosts are going to use once they are configured with the virtual IP address. Okay? So number 3, it says on D switch 1 and D switch 2, issue the necessary commands to display the VRRP status. What VRRP group is configured? what is the range of values you can configure on a VRRP group ID. So on D switch 1, let's do an exit. Let's do an exit again. Let's do a show VRRP. Okay, let's do the same thing over here on D switch 2. Let's actually just do an end here, and let's do a show VRRP. Okay, so the first question was, what is the group number that is configured? We can see the group number that is configured is group 100 on D switch 1. On D switch 2. And on D switch 1, it also has a group number of 100. It says, what is the range of values you can configure for a VRRP group ID? The ranges that we can configure for a group ID is from 1 to 255. Let's confirm that with Boson though. Yes, so it says a VRRP group is identified with a group number in the range from 1 to 255, okay? So on number 4, it says, based on the output of show VRRP command on D switch 1 and D switch 2, what virtual MAC address has been configured for VRRP? What is the role of a VRRP virtual MAC address? So as we can see, the virtual MAC address is not here. Oh, yes, it is. It's right here. Virtual MAC address is 000 period 5E00 period 0164 on D switch 1. And it is the same thing over here on D switch 2, which is 000 period 5E00 period 0164. And the role of the VRRP virtual MAC address is to respond to ARP requests that are ARPing to this IP address, which is 192.168.100.254. Our end devices are going to send that as a broadcast out on the network saying, whoever has the IP address of 192.168.100.254, what is your MAC address? And in this case, since D switch 1 is the master, it will respond to that ARP request and send this virtual MAC address. And then from there, our PCs will be able to use the default gateway and get out to the internet or do what they want to do on the internet. Okay, so number 5 says, on D switch 1, issue the necessary commands to disable the VLAN 100 interface. What output is displayed on the console after you issue the command? And what state is the VRRP on D switch 1 after you issue this command? So on D switch 1, let's do a configure terminal. Let's go into interface for VLAN 100, and we want to do a shutdown here. And as we can see, the VRRP state for D switch 1 has went from master to init. So now it is in the init state, and it is no longer going to be participating basically in our VRRP group. All right. So number 6, it says, examine the console of D switch 2. What new output do you see there? And what state is VRRP on D switch 2 after you disable the VLAN 100 on D switch 1? So if we go over to D switch 2, as you can see, it went from being the backup, it is now the master. Okay, so now because D switch 1 is disabled, D switch 2 has taken over as the master, and now our end devices will still be able to get out to the internet, even if one of these layer 3 switches fail, because we are using VRRP, which is a first hop redundancy protocol, which gives us multiple devices we can use as the default gateway in case one of those fails. Okay, so this is the benefit of using a first hop redundancy protocol. So number 7, it says, on host 1, host 2, host 3, host 4, and host 5, issue the necessary commands to change the default gateway to a virtual IP address of 192.168.100.254. So that is the virtual IP address that we are using. So let's go ahead and configure that on each device. Let's do an IP config / default gateway of 192.168.100.254. All right, do the same thing on host 2. IP config / default gateway of 192.168.100.254. Do it on host 3. IP config / default gateway of 192.168.100.254. Do it on host 4. IP config / default gateway of 192.168.100.254. And lastly, on host number 5, let's do an IP config / default gateway of 192.168.100.254. Hit enter there. All right, so on number 8, it says from host 1, trace the path to router 2's loopback 0 interface, which has an IP address of 172.16.1.2. To what device does host 5 send its traffic? To what device does host 5 send its packets for forwarding? So on host 5, let's do a trace route to 172.16.1.2, which is router 2. And we're doing this from host, or it should be from host 1. So it should be from host 1. So go to host 1. We're here now. And we want to do a trace to this IP address. And we can see our first hop was 192.168.100.4. So if we take a look at our IP address table, we can see that our first hop was dswitch 2. And that's because dswitch 1 is no longer participating because we shut down the VLAN 100 interface. So now our end hosts are using dswitch 2 as the default gateway. So that's the first hop. And then the next hop was 192.168.100.2, which it reaches router 2. And from there, it's able to get to the loopback 0 interface. Okay, so looks good. So number 9, it says from host 5, trace the path to router 2's loopback 0 interface, which has an IP address of 172.16.1.2. To what device does host 5 send its packets for forwarding? So to go to host 5, and we want to do a trace route to 192.168.1.2. And it also uses the first hop of 192.168.100.4, which is dswitch 2. And then it gets to router 2, to 192.168.100.2, and then it's able to go to the loopback 0 interface. So number 10, it says on dswitch 1, issue the commands to enable the VLAN 100 interface. To what state does VRRP transition dswitch 1 and on dswitch 2? So if we re-enable the VLAN 100 interface, dswitch 1 should then take back over as the master router. So let's do a no shut. Okay, and yep, as we can see, it has now taken back over as the master router. And if we go over back to dswitch 2, it should be the backup now. And as you can see, it has transitioned from master to the backup. And that's because it has a lower priority. It has a priority of 90. And dswitch 1 has a priority of 100. And as we know, preemption is already enabled by default for VRRP. Okay, so number 11, it says on both host 1 and host 5, trace the path from each host to the router 2's loopback 0 interface. To what device does each host forward its packets now? So it should go through dswitch 1 because it is now the master. So let's go to host 1 and prove it. We seen the first hop before was 192.168.100.4. It should be different this time. And it is. The first hop now is 192.168.100.3. And that should be dswitch 1's IP address, which it is, as we can see right here. It is. So it goes to dswitch 1, then it goes to router 1, and then it goes to router 2. And if we do the same thing over here on host 5, it should also have changed its default gateway. And it should now use router 1 as the first hop instead of router 2. As we seen before, it used router 2. So let's see if it changed. And it did. So it uses dswitch 1 first. Then it goes to router 1. And then it goes to 203.0.113.2, which is router 2. Okay? So that looks to be the end of this lab. Let's hit grade and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I will see you in the next one.